January 17th, 1991, 3:00 a.m. Baghdad time. Major Greg Feast flew his F-117 Nighthawk stealth fighter through Iraqi airspace at 20,000 feet, invisible to the sophisticated Soviet-built air defense network that had failed to detect his approach. The Global Positioning System receiver in his cockpit displayed his exact position with 10-meter accuracy, despite total darkness, cloud cover, and hundreds of miles from the nearest ground reference point. His target coordinates were programmed precisely. Iraqi Air Force headquarters in downtown Baghdad, a massive concrete structure surrounded by residential buildings and civilian infrastructure. The target folder specified not just the building, but a specific vulnerability: the ventilation shaft on the structure's roof. The shaft was approximately 1 meter square. Missing it meant the 2,000-pound GBU-27 paveway thrower laser-guided bomb would impact the building's exterior, causing damage, but not destroying the hardened command center deep inside. Hitting it meant the bomb would travel down the shaft, through the building's interior, and detonate inside the command center with devastating effect. Feast released the bomb at the programmed point. The laser designator illuminated the ventilation shaft with invisible infrared energy. The bomb's seeker head detected the reflected laser energy, adjusted its fins, and guided toward the designated point. 8 seconds after release, the bomb entered the ventilation shaft traveling at 900 feet per second. 2 seconds later, it detonated inside the command center. The building collapsed internally, while the exterior walls remained largely intact. Iraqi Air Force command and control capability for the Baghdad sector was destroyed completely. Adjacent buildings sustained minor damage from debris. Civilian casualties were 0. 1 bomb, 1 target, surgical precision. 3,000 miles away in Moscow, Soviet general staff officers watched CNN broadcast footage of precision strikes throughout Baghdad. The images showed bridges destroyed with single bombs, communication centers obliterated by individual aircraft, command bunkers penetrated by munitions guided with impossible accuracy. Soviet military doctrine had no framework for understanding what they were witnessing. Major General Viktor Yesin, Soviet Strategic Rocket Forces, expressed the confusion succinctly in a classified assessment written days into the air campaign. American forces are conducting warfare we do not recognize. Our doctrine assumes area bombardment, mass casualties, and destroyed cities. The Americans are destroying Iraqi military capability while leaving Baghdad's civilian infrastructure largely functional. This is not warfare as we understand it. This is something new. The Global Positioning System had revolutionized warfare. The Soviet Union was watching a demonstration of capabilities they dismissed as theoretical impossibilities. The era of precision warfare had begun, and Soviet military planning was already obsolete. Soviet military doctrine developed during World War II emphasized overwhelming firepower and acceptance of massive casualties as necessary costs of victory. The Great Patriotic War cost the Soviet Union 27 million dead, destroyed thousands of cities and towns, and devastated infrastructure across Western Russia. But it achieved victory over Nazi Germany. Soviet military planners internalized the lesson. War meant total mobilization, mass destruction, and victory through superior numbers and firepower. Bombing doctrine reflected this philosophy. Soviet Air Force training emphasized area bombardment using unguided iron bombs. Precision was not priority. Hitting general target areas was sufficient because the goal was destruction of enemy industrial capacity, transportation networks, and military concentrations. Individual buildings didn't matter. Entire industrial districts, entire military bases, entire cities were legitimate targets. The Battle of Stalingrad demonstrated Soviet approach to urban warfare. From August 1942 through February 1943, German and Soviet forces systematically reduced the city to rubble through artillery bombardment, aerial bombing, and house-to-house fighting. The city was destroyed, but Soviet forces achieved strategic victory. The lesson absorbed by Soviet military planners was that urban combat meant destroying the city. The Battle of Berlin followed similar pattern. Soviet artillery pounded the city with over 1.8 million shells during the final assault in April 1945. The bombardment destroyed vast areas of the city, but also destroyed German defensive positions. Soviet doctrine accepted massive destruction as necessary to achieve victory against determined resistance. Afghanistan operations in the 1980s continued emphasizing overwhelming firepower. Soviet forces facing insurgent resistance in Afghan villages responded with artillery bombardment and aerial bombing that destroyed entire settlements. The tactic was militarily effective at clearing resistance, but politically catastrophic, generating more insurgents than it eliminated. But Soviet military doctrine had no concept of surgical strikes. When facing resistance in a village, the solution was destroying the village. Soviet navigation systems reflected technological limitations and doctrinal assumptions. Inertial navigation systems provided approximate positioning through accelerometer and gyroscope measurements, but the systems accumulated errors over time. After several hours of operation, position errors could reach several kilometers. Radio beacons provided navigation references, but the beacons were vulnerable to jamming and provided coverage only in specific areas. Visual navigation using maps and terrain features worked during daylight with good visibility, but was impossible at night or in bad weather. The Soviet GLONASS satellite navigation system began development in the mid-1970s as Soviet response to American GPS development. By 1991, 8 GLONASS satellites were operational, less than the 24 satellites required for global coverage. The system provided positioning accuracy of approximately 100 meters under optimal conditions, 10 times worse than GPS military accuracy. The incomplete constellation meant coverage was intermittent and unreliable. Soviet assessment of precision-guided munitions was consistently skeptical. American development of laser-guided bombs during the Vietnam War was acknowledged, but Soviet analysts argued the systems were impractical for large-scale warfare. Laser guidance required clear weather, continuous illumination of targets, and exposed aircraft to enemy defenses. Soviet conclusion was that precision weapons were expensive novelties suitable only for limited strikes in permissive environments. Soviet General Staff planning assumptions for major war, particularly nuclear war against NATO, envisioned massive casualties and destroyed cities. Precision was irrelevant when targets included entire urban industrial complexes, military bases covering square kilometers, and NATO force concentrations. Soviet nuclear doctrine accepted that any major war would destroy civilization. Precision made no sense in context of megaton warheads destroying entire cities. This doctrinal framework made Soviet military planners fundamentally unable to comprehend warfare, as demonstrated during Desert Storm. The concept that military targets could be destroyed while leaving surrounding civilian infrastructure intact contradicted Soviet understanding of how warfare worked. The idea that precision could be more effective than mass bombardment violated principles Soviet doctrine considered fundamental truths. American development of the global positioning system began from different set of requirements and different technological philosophy. The system originated from ballistic missile guidance needs. Intercontinental ballistic missiles required accurate positioning of launch sites and precise trajectory calculations to hit targets thousands of miles away. Submarine-launched missiles faced additional challenge of determining submarine position when launching from underwater. Project 621B initiated GPS concept studies in 1963. Various proposals were evaluated throughout the 1960s, but funding limitations prevented major development. The Navstar GPS program was formally approved in 1973, with mandate to develop satellite-based navigation system providing global coverage with unprecedented accuracy. The system architecture was elegant. 24 satellites would orbit Earth in 6 orbital planes at altitudes around 22,100 kilometers. Each orbital plane would contain 4 satellites arranged so at least 4 satellites were visible from any point on Earth at any time. Each satellite would broadcast precise time signals synchronized to atomic clocks, along with data describing the satellite's position. GPS receivers would detect signals from multiple satellites and calculate position through triangulation. Since radio signals travel at known speed, the speed of light, measuring the time delay between signal transmission and reception revealed the distance from receiver to satellite. With distance measurements from 4 satellites and knowing each satellite's position, the receiver could calculate its own 3-dimensional position and accurate time. The system's elegance was its simplicity from the user perspective. Receivers didn't transmit anything. They only listened to satellite broadcasts. This meant unlimited users could operate simultaneously without interfering with each other. The satellites provided positioning service to anyone with a receiver regardless of where they were or what they were doing. The ground segment maintained system accuracy. Control stations around the world monitored satellite signals, calculated orbital positions to extreme precision, and uploaded corrections to satellites. The system was designed to provide 10-meter accuracy for military users with encrypted access and degraded 100-meter accuracy for civilian users through selective availability, deliberate introduction of positioning errors to prevent adversaries from using GPS for military purposes. The first GPS satellite, Navstar 1, launched on February 22, 1978. The launch marked transition from concept to operational system. Additional satellites were launched throughout the early 1980s, gradually building toward the full 24-satellite constellation required for continuous global coverage. Development faced setbacks. The Space Shuttle Challenger disaster in January 1986 halted launches for nearly 3 years, delaying GPS constellation completion. Budget constraints and technical problems slowed progress. By 1991, only 16 GPS satellites were operational, 2/3 of the planned constellation. But the coverage over the Middle East was sufficient for continuous GPS availability. GPS applications extended far beyond navigation. The system's accurate positioning enabled precision-guided munitions to find targets with unprecedented accuracy. The Joint Direct Attack Munition Program, initiated in 1992, would create GPS-guided bombs that could hit within 10 meters of designated coordinates, regardless of weather, time of day, or visibility. The concept revolutionized air warfare by making precision strikes routine rather than exceptional. Military logistics benefited enormously from GPS. Supply convoys could navigate directly to units regardless of terrain. Artillery batteries could determine exact positions without traditional surveying that required hours or days. Infantry units could coordinate movements with precision impossible using map and compass. The system touched every aspect of military operations. But in January 1991, GPS was still emerging technology. The incomplete constellation meant the system wasn't yet meeting its design specifications. Military planners weren't certain GPS would perform reliably under combat conditions. Some officers questioned whether GPS signals could be jammed or spoofed by Iraqi forces. The Gulf War would be GPS's first large-scale combat test. Operation Desert Storm planners faced challenging requirements. The coalition needed to defeat Iraqi forces with minimal American casualties. Public support for the war would collapse if casualties approached Vietnam War levels. Simultaneously, the coalition needed to minimize Iraqi civilian casualties to maintain international support and prevent the conflict from being portrayed as Western slaughter of Arabs. These requirements demanded precision. Destroying Iraqi military capability while preserving civilian infrastructure meant individual targets had to be struck accurately. Missing targets meant wasted sorties and potential civilian deaths. The technology to enable precision existed, but it had never been tested at this scale. GPS availability during Desert Storm was not guaranteed when planning began. Military planners ordered commercial GPS receivers as backup to military systems. By the time ground operations began, approximately 4,500 commercial GPS receivers had been procured and distributed to ground units. The commercial receivers lacked encryption to access full GPS accuracy, but they provided positioning good enough for navigation and coordination. Navigation across featureless desert was the first challenge GPS solved. Saudi Arabian and Iraqi deserts offered few terrain features for traditional map and compass navigation. During daylight with good visibility, vehicle convoys could navigate using terrain association. At night or during sandstorms, Navigation became guesswork. Units could become lost within hours of departure. GPS changed everything. A convoy commander with GPS receiver knew his exact position regardless of visibility, weather, or time of day. He could navigate directly to coordinates without following roads or terrain features. He could maintain formation with other units separated by miles of desert because everyone knew their positions precisely. The capability seemed mundane, but was revolutionary. The coalition ground offensive launched on February 24, 1991. American 7 Corps and 8th Airborne Corps attacked through southern Iraq in massive sweeping movements designed to outflank Iraqi defenses and destroy Republican Guard units. The operations required coordinating hundreds of thousands of troops, thousands of vehicles, and complex logistics across 250-plus miles of mostly featureless terrain. Soviet military planners watching Desert Storm preparations assumed the coalition would advance slowly, pausing frequently to confirm positions and coordinate movements. Soviet doctrine assumed that large-scale maneuvers through unfamiliar terrain required careful reconnaissance, detailed maps, and constant position confirmation. Rapid advances were impossible without risking units becoming disoriented and scattered. The coalition advanced at speeds Soviet planners considered impossible. Armored columns moved 50 to 100 miles per day while maintaining formation and reaching objectives on schedule. Units separated by dozens of miles coordinated movements precisely. Artillery batteries moved, set up, fired missions, and displaced to new positions with efficiency that required knowing exact positions throughout. The explanation was GPS. Battalion commanders knew their positions constantly. They knew where adjacent units were located. They could call for artillery support and provide precise coordinates. They could coordinate with air support and identify their locations to prevent fratricide. The speed and precision of coalition maneuvers reflected technological capability that Soviet doctrine assumed didn't exist. Artillery operations demonstrated GPS impact on traditional combat arms. Soviet doctrine required artillery batteries to spend hours or days conducting surveys to determine exact firing positions. Accurate fire required knowing precisely where the guns were located, calculating trajectories that accounted for weapon position, target position, and environmental factors. The surveying process was time-consuming but necessary for accuracy. American artillery batteries equipped with GPS eliminated surveying requirements. Commanders could position batteries, confirm locations via GPS in seconds, and begin firing immediately. The multiple launch rocket system demonstrated the capability. GPS positioning combined with inertial guidance enabled MLRS batteries to deliver accurate fire at 45-kilometer ranges within minutes of arriving at firing positions. Iraqi forces accustomed to Soviet-style artillery doctrine were shocked by American artillery responsiveness. American batteries fired accurate missions within minutes of being called. Iraqi forces attempting to ambush American convoys found themselves under artillery fire before they could complete their attacks. The speed of American artillery response reflected GPS, enabling immediate position confirmation and fire mission calculation. Precision bombing demonstrated most dramatically how GPS changed warfare. F-117 Nighthawk stealth fighters used GPS navigation to reach targets in defended airspace. The aircraft were invisible to radar, but they still needed to navigate precisely to target areas. GPS provided navigation accuracy that enabled F-117s to reach specific buildings in downtown Baghdad without visible references or radio navigation aids. Laser-guided bombs finished what GPS navigation enabled. The GBU-10 Paveway 2 and GBU-27 Paveway 3 bombs used semi-active laser guidance. Aircraft or ground designators illuminated targets with laser energy, bombs guided toward reflected laser light. The guidance was accurate to within meters when systems worked properly. Combined with GPS navigation placing aircraft in correct positions, the result was precision strikes against individual buildings. The contrast with previous conflicts was stark. During the Vietnam War, American forces conducted Operation Rolling Thunder bombing campaign against North Vietnamese targets, including the Tan Hoa Bridge. The bridge was critical supply route for North Vietnamese forces. American aircraft flew over 700 sorties against the bridge between 1965 and 1968, dropping thousands of bombs. The bridge was damaged repeatedly, but remained operational until 1972, when laser-guided bombs destroyed it in single strike. Desert Storm reversed the efficiency equation. Instead of hundreds of sorties to destroy one bridge, F-117s destroyed bridges with single aircraft carrying 2 bombs. Iraqi Air Force headquarters, communications centers, and command bunkers were destroyed with individual strikes. The difference wasn't just accuracy, it was fundamental change in how air power achieved effects. Baghdad illustrated the revolution most clearly. The city was heavily defended by Soviet-built air defense systems including SA-2, SA-3, SA-6, and SA-8 surface-to-air missiles, plus thousands of anti-aircraft artillery pieces. Soviet doctrine assumed that air defenses would force attacking aircraft to high altitudes where accuracy was impossible, or low altitudes where losses would be catastrophic. F-117s operated at medium altitudes where Soviet air defenses were least effective, while GPS navigation and laser guidance enabled precision strikes. Iraqi command centers, communications facilities, and government buildings were destroyed methodically, while adjacent civilian structures remained intact. Television broadcast facilities were destroyed, while residential neighborhoods surrounding them were largely undamaged. Soviet military observers watching CNN coverage from Moscow couldn't understand what they were seeing. Soviet doctrine assumed bombing Baghdad would require carpet-bombing residential districts where command facilities were located. The Americans were destroying individual buildings in dense urban environment while leaving surrounding structures intact. The capability contradicted Soviet understanding of how bombing worked. Statistical analysis revealed precision weapons impact. Only 7% of bombs dropped during Desert Storm were smart weapons, laser-guided or GPS-aided munitions. The remaining 93% were unguided iron bombs used for area targets or delivered by aircraft like B-52s conducting carpet bombing. But intelligence assessments concluded smart weapons caused approximately 75% of Iraqi military damage, despite being only 7% of bombs dropped. The efficiency gain was enormous. One sortie with precision weapons achieved effects requiring 10 or more sorties with unguided bombs. Fewer sorties meant less exposure to air defenses, less fuel consumption, less wear on aircraft, and faster achievement of objectives. Precision wasn't just more accurate, it was more efficient in every dimension. Logistics operations benefited from GPS in ways Soviet planners didn't initially recognize. Coalition forces required massive supply operations, moving fuel, ammunition, food, water, and equipment across hundreds of miles of desert. Soviet doctrine assumed supply convoys would require extensive reconnaissance, marked routes, and periodic position checks to avoid getting lost. Coalition supply convoys navigated using GPS. Drivers knew their exact positions and could navigate directly to destinations. Lost convoys, a common problem in featureless terrain, became rare. Supply delivery times became predictable. Units received supplies on schedule because GPS navigation eliminated the uncertainty of desert navigation. The compound effects were significant. Faster supply delivery meant units could maintain higher operational tempo. Predictable logistics meant commanders could plan operations, confident supplies would arrive when needed. Reduced convoy losses meant more supplies reached frontline units. GPS impact on logistics was less dramatic than precision bombing, but equally important to overall campaign success. Soviet military leadership watching Desert Storm unfold recognized immediately that Soviet doctrine was obsolete. The warfare being demonstrated contradicted fundamental assumptions about how modern war would be conducted. Several realizations emerged from Soviet analysis. Navigation systems were generation behind American capabilities. GLONASS remained incomplete and inaccurate compared to GPS. Soviet forces still relied primarily on 1960s-era inertial navigation systems supplemented by maps and visual references. The capability gap meant Soviet forces couldn't coordinate movements with precision Americans demonstrated routinely. Precision munitions were dramatically more effective than Soviet assessments predicted. Soviet skepticism about precision weapons' practicality was proven wrong. Americans weren't using precision weapons in small numbers for specialized missions. They were using them systematically to achieve strategic effects. Soviet forces possessed limited precision weapons and lacked doctrine for employing them effectively. System integration was far more advanced in American military than Soviet planners understood. GPS wasn't just a navigation system. It was integrated into weapons, logistics, communications, and command systems. The integration multiplied effectiveness of individual systems. Soviet forces had separate systems for separate functions with minimal integration. Training reflected different military philosophies. American forces trained to use precision systems effectively. Pilots practiced precision strikes. Artillery crews trained GPS-equipped fire missions. Infantry learned GPS navigation. Soviet forces trained for mass firepower tactics that GPS-enabled precision rendered obsolete. Changing tactics required retraining entire force. The cost assumptions were revealed as fundamentally wrong. Soviet analysis had argued precision weapons were too expensive for large-scale use. Desert Storm demonstrated precision weapons saved money overall. Fewer sorties meant less fuel, less maintenance, less exposure to losses. Faster victory meant lower overall costs. Precision was cost-effective, not cost-prohibitive. Soviet post-war analysis was extensive and remarkably candid. Classified assessments acknowledged that American technological advantages were wider than Soviet intelligence had estimated. The reports recommended accelerated development of GLONASS, increased investment in precision munitions, study of GPS vulnerabilities including jamming and anti-satellite weapons, and fundamental revision of military doctrine to incorporate precision warfare concepts. But closing the gap required decades. GLONASS wasn't fully operational until 2011. 20 years after Desert Storm. Russian precision munitions development accelerated, but remained behind American systems. Military doctrine was revised, but implementing new doctrine required re-equipping and retraining forces. The reforms were ongoing when the Soviet Union collapsed in December 1991, and subsequent Russian military faced funding shortages that delayed modernization. The comprehensive legacy of GPS extends far beyond military applications. The system revolutionized warfare permanently, influenced civilian technology development, and established precedent for space-based infrastructure supporting national power. Military applications of GPS expanded continuously from Desert Storm forward. The Joint Direct Attack Munition Program created GPS-guided bombs that entered service in 1997. JDAMs converted unguided iron bombs into precision weapons by adding GPS guidance kits. The transformation was dramatic. A 500-pound bomb that cost $200 became precision weapon costing $25,000 total, orders of magnitude cheaper than previous precision weapons. JDAM accuracy was 13 meters in optimal conditions and proved remarkably reliable across all weather conditions. Excalibur GPS-guided artillery shells brought precision to artillery previously dependent on accuracy, degrading with range. The M982 Excalibur 155mm shell used GPS guidance to achieve 2-meter accuracy at ranges exceeding 40 kilometers. The capability fundamentally changed artillery doctrine. Instead of firing dozens of shells to ensure target destruction, artillery batteries could fire single precision rounds and achieve effects that previously required sustained bombardment. Tomahawk cruise missiles incorporated GPS navigation in Block 3 and Block 4 variants. The missiles could fly hundreds of miles, navigate using GPS, and strike targets with precision comparable to manned aircraft. The capability provided commanders with long-range precision strike options without risking pilots. Unmanned aerial vehicles became practical through GPS navigation. Predator and Reaper drones use GPS for navigation, enabling operators thousands of miles away to control aircraft precisely. The drones revolutionized warfare by providing persistent surveillance and strike capability without risking pilots. GPS was fundamental enabling technology. Without accurate navigation, remote operation would be impossible. Individual soldier positioning became standard through GPS-equipped radios and personal navigation devices. Infantry squad leaders could see positions of adjacent squads on digital displays. Commanders could track unit locations in real time. The capability reduced fratricide risks, enabled better coordination, and improved situational awareness at all levels. Civilian applications of GPS exploded after selective availability was turned off in May 2000. President Bill Clinton's directive made full GPS accuracy available to civilian users, enabling revolutionary applications: smartphone navigation, vehicle GPS systems, aviation navigation, maritime shipping, precise agriculture, surveying, and countless other applications became possible. GPS enabled economic value estimated in hundreds of billions of dollars annually. The technology proliferated globally. The European Union developed Galileo navigation satellite system. China developed Beidou. Russia completed GLONASS. India developed NAVIC regional system. Japan and other nations developed regional augmentation systems. But GPS maintained first-mover advantage. 2 decades of operational experience, widest receiver availability, and complete global coverage gave GPS advantages competitors struggled to match. The strategic implications of GPS dependence became clear to military planners. American military forces had become so dependent on GPS that system failure would cripple operations. Anti-satellite weapons capable of destroying GPS satellites became strategic priority for potential adversaries. Jamming and spoofing GPS signals became recognized threats. American military invested heavily in GPS resilience, backup navigation systems, and defensive capabilities to protect satellites. Desert Storm legacy shaped American military transformation during the 1990s and beyond. The conflict validated precision warfare concept and demonstrated that technology could minimize casualties while maximizing effectiveness. Subsequent military operations emphasized precision strikes, minimal collateral damage, and surgical targeting. The approach became default American military doctrine. Soviet and later Russian military forces recognized technological gaps exposed by Desert Storm and attempted to close them. But the head start American forces possessed, GPS operational years before GLONASS, doctrine emphasizing precision, while Soviet doctrine emphasized mass firepower, integrated systems while Soviet systems remained separate, proved difficult to overcome. Russia invested heavily in military modernization during the 2000s and achieved significant progress, but gaps remained. The broader lesson transcended GPS specifically. Desert Storm demonstrated that technological superiority in information systems, precision weapons, and system integration could defeat numerically superior forces decisively. Iraqi military, using Soviet equipment and Soviet doctrine, was systematically defeated by coalition forces using American technology and American doctrine. The lesson influenced military forces globally. Nations recognized that matching American technological capabilities required sustained investment in advanced systems and fundamental changes to military doctrine. GPS impact on warfare was revolutionary, not because it made individual operations possible, but because it made precision routine. Precision strikes existed before GPS. Laser-guided bombs had been used since Vietnam. But GPS made precision strikes routine, repeatable, and achievable in conditions where previous technology would fail. The transformation from exceptional capability to routine operation changed warfare fundamentally. Soviet military planners had spent decades preparing for World War III that would resemble World War II. Massive armored formations, artillery barrages lasting hours or days, acceptance of enormous casualties, and systematic destruction of enemy population and industrial centers. Nuclear weapons made the vision even more apocalyptic, but the fundamentals remained. War meant mass destruction and millions dead. GPS enabled different vision of warfare. Precision strikes could destroy military capabilities while preserving civilian infrastructure. Technology could minimize casualties rather than accepting them as inevitable. Victory could be achieved through superior information and precision rather than superior numbers and firepower. The shift wasn't incremental improvement, It was paradigm change in how warfare was conceived and conducted. The transformation was visible in Baghdad throughout January and February 1991. The city was capital of nation at war, home to military command centers, communications facilities, government buildings that controlled Iraqi military operations. Soviet doctrine would assume destroying those facilities required carpet-bombing residential districts where they were located. The resulting civilian casualties would be enormous, but accepted as necessary cost of military victory. American forces destroyed the facilities with surgical precision. Buildings were struck individually. Adjacent structures remained intact. Civilian casualties were minimized not through luck, but through deliberate application of technology enabling precision strikes. The capability demonstrated that warfare could achieve military objectives without the mass destruction Soviet doctrine considered inevitable. The philosophical implications extended beyond tactics and technology. Soviet doctrine reflected materialist worldview, where victory required destroying enemies' material capability to wage war. American doctrine increasingly reflected information age worldview, where victory required destroying enemies' ability to coordinate and command forces. The distinction was subtle but profound. Materialism emphasized destroying things. Information age emphasized disrupting systems. GPS was information technology applied to warfare. It didn't destroy targets directly. It enabled precise navigation, positioning, and coordination that multiplied effectiveness of weapons and forces. The technology was force multiplier that made existing capabilities far more effective. Soviet military planners trained to think in terms of firepower, and numbers struggled to understand how information superiority could defeat material superiority. Major General Viktor Yesin's assessment written during Desert Storm captured Soviet confusion. The Americans are achieving effects we would require 10 times as many sorties to achieve. They are coordinating hundreds of thousands of troops across territory that should require weeks to traverse. They are striking individual buildings in defended urban areas with success rates we consider impossible. This is not incremental advantage. This is warfare operating on principles we do not fully understand. The assessment was accurate. Soviet military doctrine wasn't slightly behind American doctrine. It was built on fundamentally different assumptions about what was possible and necessary in warfare. GPS and associated precision technologies didn't just improve American military effectiveness. They enabled an entirely different approach to warfare that Soviet doctrine hadn't anticipated. The gap wasn't 10 meters versus 100 meters of positioning accuracy, though that was visible manifestation. The gap was between military doctrines developed in different eras, reflecting different technological capabilities and different philosophies about warfare's purpose. Soviet doctrine developed during World War II assumed mass destruction was inevitable and necessary. American doctrine developed during Information Age assumed precision could achieve effects more efficiently than mass destruction. Desert Storm demonstrated which philosophy was correct for modern warfare. Soviet-style mass firepower tactics were defeated by American precision. Iraqi forces using Soviet equipment, Soviet doctrine, and Soviet training methods discovered their entire approach to warfare was obsolete. The demonstration influenced military thinking globally and accelerated precision weapons development worldwide. The final irony was economic. Soviet analysis before Desert Storm argued precision weapons were too expensive for large-scale use. The analysis was wrong on multiple levels. Precision weapons saved money by reducing sorties required, minimizing aircraft losses, and shortening wars. GPS development cost approximately $12 billion from concept through initial operational capability. Expensive but trivial compared to cost of maintaining Cold War military forces or conducting extended conflicts. The civilian economic benefits of GPS exceeded military costs by orders of magnitude. The system generated hundreds of billions of dollars in economic activity annually through navigation, timing, and positioning services. American investment in GPS returned value far exceeding development costs even before considering military benefits. Soviet Union spent comparable amounts on GLONASS, but took 20 additional years to achieve operational capability. The delay meant GPS established worldwide dominance in navigation applications before GLONASS was available. Russian investment achieved functional system, but not competitive advantage. The first mover benefit was immense. Modern warfare is unimaginable without GPS. Every weapon system relies on satellite navigation. Every military operation depends on precise positioning. Every logistics operation uses GPS for navigation and tracking. American military forces have become so dependent on GPS that protecting the system from attack is strategic priority. Anti-satellite weapons, jamming systems, and cyber attacks threaten GPS, prompting investment in defensive measures and backup systems. The dependence reflects GPS's comprehensive success. System designed for navigation evolved into fundamental infrastructure supporting information-age warfare. Position, navigation, and timing data. GPS provides enable coordination, precision, and efficiency impossible through alternative means. Destroying GPS would cripple American military operations more effectively than destroying equivalent number of conventional assets. Potential adversaries recognize GPS as vulnerability and opportunity. Chinese military doctrine emphasizes anti-satellite capabilities as method to offset American technological advantages. Russian military has developed extensive GPS jamming capabilities. Both nations developed independent navigation satellite systems, partially to reduce dependence on American system, and partially to provide alternatives if GPS became unavailable. But GPS advantages remain insurmountable for most nations. The system is free to use, provides global coverage, and has mature ecosystem of receivers and applications. Developing comparable system requires billions of dollars and decades of effort. Nations may develop independent systems, but GPS maintains dominant market position through network effects and first-mover advantages. The legacy of Desert Storm extends beyond GPS, specifically to broader principle about military innovation. American military forces demonstrated that sustained investment in advanced technology, combined with doctrine exploiting that technology and training enabling effective use, could defeat numerically superior forces decisively. The lesson was expensive. GPS development cost billions, precision weapons were expensive to develop and procure, training required extensive investment, but the results validated the investment. Soviet military spent comparable amounts on different priorities: larger numbers of weapons, more armored divisions, extensive nuclear arsenals. Soviet forces possessed quantitative advantages in most categories, but were defeated by qualitative advantages they hadn't anticipated. The demonstration influenced military procurement and doctrine development worldwide. Nations recognized that matching American technological capabilities was necessary for military competitiveness. The transformation continues today. GPS was first space-based system enabling precision warfare. Subsequent developments, including reconnaissance satellites, communication satellites, early warning satellites, and navigation satellites, created comprehensive space infrastructure supporting military operations. Space became new domain of warfare as critical as land, sea, and air. Nations building military forces must now invest in space capabilities or accept permanent disadvantage against adversaries who have them. Soviet Union spent 40 years preparing to fight next World War II. American military invested in technologies enabling fundamentally different approach to warfare. When Desert Storm demonstrated the capabilities American investment had created, Soviet military leadership recognized their doctrine was obsolete. The reforms that recognition prompted were ongoing when Soviet Union collapsed. Russian military inherited the problem and spent subsequent decades attempting to close gaps while managing dramatically reduced budgets. The gap remains visible today in military operations worldwide. American forces conduct precision strikes routinely. Russian forces, despite improvements, still rely heavily on mass firepower tactics reminiscent of Soviet doctrine. The difference reflects decades of investment, doctrinal development, and training emphasis that created systematic advantages difficult to replicate or overcome. GPS-guided precision strikes in Desert Storm marked watershed moment in military history. Warfare had fundamentally changed from mass destruction to surgical strikes, from carpet bombing to precision targeting, from accepting massive casualties to minimizing them through technology. Soviet military doctrine built on World War II experience was rendered obsolete by American innovation creating information-age warfare. The gap wasn't incremental. It was revolutionary transformation that Soviet planners hadn't anticipated and couldn't quickly counter. GPS provided 10-meter accuracy, while GLONASS provided 100-meter accuracy. But more fundamentally, GPS enabled comprehensive transformation of warfare, while Soviet military remained committed to doctrine, assuming precision was impractical and mass destruction was inevitable. Major Greg Feast's bomb traveling down ventilation shaft into Iraqi Air Force headquarters symbolized the transformation. Soviet doctrine would require destroying entire city blocks to eliminate that headquarters. American technology destroyed the building surgically while leaving surrounding structures intact. The difference represented decades of investment, different philosophy about warfare's conduct, and technological capabilities that enabled precision warfare at scale. Soviet Union watched Desert Storm unfold on CNN and recognized their military doctrine was obsolete. American forces were conducting warfare. Soviet planners didn't recognize, achieving effects Soviet doctrine considered impossible, and demonstrating technological superiority. Soviet leadership hadn't fully comprehended. The era of smart warfare had begun. Soviet-style mass firepower doctrine was history, and GPS-enabled precision strikes had changed warfare permanently.